Hello, my name is Evan Zhu. I am a lifelong Chapel Hillian who's lived here my whole life, who is studying chemistry at UNC. And I want to be a chemistry LA for Organic 1 because I've always found that talking through a problem when I'm trying to solve it really helps me understand the problem as much as it helps the other person I'm talking to understand the problem a lot better, like conceptually. And I've always felt that it makes me a lot more confident when I talk through things with someone. And in turn, I want to give that same confidence to more students who are taking Orgo 1, who feel that Orgo 1 is like an impossibly difficult class because of the reputation it's garnered. But I feel that success can come in many ways, and there's not just one way to succeed in the class. I think taking it this semester, I've seen how many resources there are given to the students to succeed. And I want to help students leverage the resources that will help them the best, because I think you don't have to necessarily do everything in the class to succeed. I think finding what works well with you is really important to learning how to study effectively. And that's one of the strategies that I would bring to help students do better in the class. So now I'm gonna go through a problem. I'm choosing a problem in the workbook from the practice test section. So I'll switch over to that right now. All right, so I've got the question drawn out here. This is a pretty classic predict and draw the major products question, and it also asks us to evaluate the stereochemical outcome at the end. So to think about the major products that we would get, it's helpful to think about the mechanism that this reaction would undergo to get us to that result. So right off that, we can see that our reactive center is most likely going to be our alkene right here, because we know that alkenes are reactive. And we also see that this is catalyzed in acid, which means that we're going to have hydronium present in the solution as well. And because we know that our alkene is our nucleophile and our hydronium is our electrophile, we know that this alkene is most likely going to deprotonate this hydrogen, returning those electrons back to the oxygen, which will just give us water. And we know that because of Markovnikov's rule, this proton is actually going to get added to the less substituted side of the alkene. So this is going to give us a molecule that looks like this in the intermediate state with that positive charge on that carbon. But we know that because we're going through a carbocation intermediate, that there's the possibility for a 1,2 or a 1,2 hydride or a 1,2 methyl shift, because that could potentially make a more stable carbocation. We see that if the positive charge stays on this carbon, we get a secondary carbocation, but if the positive charge shifted to here, we would get a tertiary carbocation that's also stabilized by this resonance right here. So we know that this shift is most likely going to happen. We can draw in the hydrogens to visualize that, and we're going to end up getting the positive shift on this carbon instead, with that hydrogen being moved. So now that we have our stable carbocation, we can go ahead and do our addition of this alcohol as well, which is our other reagent. So we can see that oxygen is going to have two lone pairs right here. Oxygen is going to be our nucleophile, and this molecule is going to be our electrophile. So we know that this is going to add in right there, and we're going to end up getting a molecule that looks like this, with the alcohol group added right here after you deprotonate this hydrogen with the water that is in solution. So we know that because we're doing a carbocation intermediate, this alcohol group could add from any side, but we know that this center right here isn't actually an asymmetric center, because you've got these two alkyl groups coming off, which are the exact same. So this actually doesn't have any important stereochemistry, and we're only going to get one product as a result. So then when we're thinking about our stereochemical outcome, we know that we are only making a single product, and we know that what we're making is achiral because there are no other asymmetric centers on this molecule. Thank you. I hope this was a good explanation, and I hope you were able to follow along.